USACO 2015, January bronze, second cow routing 2. Tired of the cold winter weather on her farm, Bessie the cow plans to fly her warmer destination for vacation. Unfortunately, she discovered that only one airplane, Air Bovinia, is willing to sell tickets to cows, and that these tickets are somewhat complicated in structure. Air Bovinia owned and planes n is up to equal to 1, and smaller equal to 500, each of which flies on a specific route consisting of 2 or more cities. For example, one plane might fly a route that starts at city 1, then flies to city 5, then flies to city 2, and then finally flies to city 8. No city appears multiple times in a route. If Bessie chooses to utilize a route, she can board at any city along the route and then disembark at any city later along the route. She does not need to board at the first city or disembark at the last city. Each route has a certain cost, which Bessie must pay if she uses any part of the route. Irrespective of the number of cities she visits along the route, and Bessie may make use of a route only once. That is, she cannot use a route and then later use a different part of this same route. Bessie would like to find the cheapest way to travel from her farm in City A to her tropical destination, City B. Since she does not want to be confused by a complicated itinerary, she wants to use at most 2 routes. That is different with the version 1. Please help her decide what is the minimum cost she must pay. Note that only one difference between this problem and preceding bronze problem is here Bessie can use up to 2 routes versus only 1 route in the preceding problem. Okay, let's make info file first. So A, B, and N. So this is Bessie need to start. This is departure 1, destination 2, number of plane is 3. And then this is plane 1, plane 2, plane 3. And then this is cost, and then this one is the number of city, and this is route. So this route has 3 cities. Second, this is price. This is number of city 4. And then price, number of city 5. And then okay. I'm gonna import data from the file. So I'm gonna use import system standard input. I'm gonna open one file. Name is code root in, and then we need read mode. And then we're gonna make a file to write the result. Open cow root and out of file, and then write mode. Then if you want to check all test cases at website, you need to use this one. But in this case, I'm gonna not use this one to print out at console. So first is this one, right? So first is departure and destination, and that n is finally that we need to convert to integer, and I'm gonna input and split. Next is Prices, we need prices table, and then which table. Then for rate and time, and then we're gonna put prices offhand. Okay, now here, right? So we need only first one, right? To do that, convert integer and then split this input and split, and we just need the first item. And then root offhand, and then we're gonna put as list and then change it integer and input split. Let's check print. Departure, destination, prices, route. Looks good. So this is start, the departure, destination. This is price. Price is 348, and then this is route 321 2143 41782. So we're gonna use this one as example. Then we're gonna make new function. One input departure and destination, and this is prices, and this is route. And then out must be in this time 7. The reason is if we take here, start here, and then leave here, and then take here again, and then we find that is destination, right? So we're gonna use the train, one indexed train first, and then take here, and then take off, and then take in, and then take off. This time this one is price is 4 plus 3 is 7. That is the smaller than this one, right? Cool. So how are we able to make it? This time we're gonna use hash table. Hash table time, so time complexity must be n. N is the number of cities. Space also n, because we're gonna use hash table. So first we needed to make transfer table. So first we're gonna traverse the same as the previous one, and then we are looking the where is departure. So if we are able to transfer, we need to check after from departure, right? So in this case, this is a final, so we cannot find any city able to transfer, right? Because that is destination. But in this case, this is departure. But if the 4 is that is possible, it has possibility able to transfer. So 4, maybe we can transfer to train here, right? So, and in this case 3, there are one option able to transfer here. So actually this is the cheapest way. This is 3, and then 3 to 1. So in this time 4, and then I'm gonna put in the price 4. If we change it to another one, and then put this one price is 4, and then next 3 price 4. 4 is this L from the prices, and then after change it, we just check if this is 3 is in the 4, so we easy to calculate the 4 plus this one price is 3, so that is 4. Does this make sense? Cool. And then also we needed to destinations route. This one is route have, okay, because we just need to check the route have destination, because this one have destination right too. This one right. In this case, all of one is have destination. But sometimes some route does not have destination. No need to check it. Does this make sense? Okay, then let's dive into the code. Call route. And then we're gonna receive all of this one. First, we need the price. Price is the biggest number because we gonna save smaller one. And then we already need the destinations. We need this one. Also, we need transfer. This is prices. If we transfer at the city, and then we're gonna iterate for I in rate which this is the same as the previous question. First, we're gonna find the departure first. For city in which, if the city is departure, we're gonna, and then found must be true. Otherwise, if city is destination, there are two cases. If found departure already, and then just calculate, same as before. This is the use only one train, and then we need to break because no need to check the future cities of route. Else, just to save the destinations. Destinations offhand, the index of route. City. If found, but that is not this destination. If city, adding transfer, and then we're gonna add a new one. City is price is high. Yes, just we're gonna update. Transfer city is we're gonna use minimum price. City read current prices. For we just check the route only have destination. No need to check all, right? And then for city in which I index, if city is destination, just break. That means 2. That is destination, no need to check further one, right? This is destination, no need to check this one. Does this make sense? Yeah. So we're gonna break. If city in transfer, this is time to calculate. Price, we need to update mean. Price with price is I plus the transfer fee. city. And then finally we're gonna return prices if we found the root. Otherwise, -1. Ooh. Why we could not find it? Okay, there are some block. Let's check. Prices, destination, transfer, route to find first. See route, status departure. Find through as city's destination if found. Prices mean prices. Yeah, as destinations of found it. And if found, city not in transfer, and prices. As transfer city is mean of transfer city and prices I. Yeah, if I in destinations. For city in route I, if city is destination, it's just break. If city in transfer, mean, price, mean, C mean, prices I, transfer city. Return. Inventing. Oh. Because current iteration is on the here, but we need to iteration out of this iteration. So minus this one is prices I. Because that is in transfer, right? No. Price is correct. City. This one is looks good. Try transfer city. Okay, let me check one more time. Price. Infinity. Transfer destination. Transfer. This is root. Okay, 7. Thank you.